So welcome everyone. I'm excited to invite you to this webinar that we have arranged. I think it's the last webinar for 2020. And I'm excited to put this year behind us, just like every one of you, I hope. Today we're going to talk about how we at Sigmoid have managed to control our AWS cost and reduce it by as much as 65%. We have arranged this webinar in partnership with AWS. And I'd like to start off by introducing our panelists. So we'll start off with Kaushik from AWS. Kaushik.
Hey, thanks, Mayur. Hello all, I'm a solutions architect at Amazon working out of Bangalore, India. I help customers build reliable, scalable, and cost-effective solutions in the cloud. And I have over 12 years of experience as an entrepreneur and experienced in product development and building scalable application. I'm passionate about machine learning, healthcare, and travel, and very excited to be part of this session with you today.
Perfect. Thanks, Kaushik, for joining us today. Also have Jagan from Sigmoid. Jagan.
Hello all. Thank you for taking time out and being here today. I'm working as a DevOps architect at Sigmoid. I have 14 plus years of experience in IT industry. I've helped many customers with their cloud journey and cloud adoption. Majorly, I've contributed on architecting and implementing solution for businesses on cloud. Prior to Sigmoid, I've led 2 startups and both were around DevOps toolsets. Over to you, Mayur.
Perfect. Thanks a lot, Jagan. And finally, it's me, Mayur. I head technology and solutions for Sigmoid. I have a decade-long experience in building big data solutions and open source systems, contributing and committing to open source platforms as well. So just some basics before we start. We'll be running this presentation for about 45 minutes, and we've left about 10 minutes for Q&A. To submit the questions, click the Q&A button on the top of the panel and submit your questions. We'll try to get to all the questions till the end of the webinar. In case we are not able to, we will surely come back to you over email to respond to these questions. So, we like to kind of highlight the agenda first. We'll be starting off with a case study about how we at Sigmoid managed our AWS cost. Then we're going to bring in AWS to talk about the best practices that they recommend for cloud management practices. We're going to summarize the webinar, take questions, and close the session. So that's kind of a brief agenda. So before we start the case study, I'd like to talk about a poll that we recently ran on social media. The main question there was, what is the motivation for so many companies to start adopting the public cloud and moving there? And we found that scalability and long-term cost structures are the 2 clear winners for most companies to make that initial jump. I'd like to bring in Kaushik here and tell us if his experience is also similar in AWS.
The ability to quickly scale have always been one of a driving factor for cloud adoption, right? And combining with various tools and services, like for example, Amazon EMR, Glue, our customers are able to quickly build solutions that would normally take significant amount of resource and time, right? So yeah, I think that makes sense, Mayur.
Perfect. The other aspect is very familiar to everyone who has seen their cloud bill. That cloud computation is the most significant spend that most companies make. But I would like to kind of suggest them to keep looking at the storage cost as well, because as you kind of move and generate data on the cloud or collect data on the cloud over time for compliance and other reasons, you would slowly see this storage cost also creep up, and it's a continuously monotonically increasing cost. So we're going to talk about both of these aspects today in the webinar. But kind of why should we do that? Why should we talk about cloud cost? Fundamentally, cloud is a new phenomena for IT and business and technology teams inside the organization. And what we've found is that most of these companies are kind of overspending. About 1 in 5 are definitely overspending on their cloud cost, what they had forecasted before. It's not very different than the older world. In the older world, most IT companies used to forecast way higher than before. But in cloud environments, since it's more dynamic, people are more conscious and business is more aware of what they're spending and want to control it really well. And the second aspect, which is equally shocking, is about 30% of cloud spend ends up being wasted. It's either prototypes which didn't materialize, or it's kind of unmanaged cloud environments. So since almost 1 in 2 organizations see their cloud spend increasing, we are here to talk about how we have managed to do that on our side, managed to control cloud cost, and how you can do the same in your own environments. So to do that, I'd like to bring in Jagan to talk about our own journey on the cloud. Jagan?
Thanks, Mayur. So let me take you through our journey of cost optimization for our product SigView and NitroDB. Around 2013, we were working with AdTech domain companies for the challenges that they were facing. We found that they need to process terabytes of data per day and needed a quick insights from it. Keeping that in mind, we built SigView and NitroDB as two cloud-based analysis tools. SigView is a plug-and-play real-time data analysis tool. It allows customer to drill down massive data within few seconds. Very similar to Tableau, Power BI, ClickSense that you may be already using. NitroDB is our cloud-powered data warehouse custom built on Apache Spark, very similar to Redshift, which allows to analyze terabytes of data. Mayur, can you go to the next slide? So when we were building the product, there were 4 focus areas that we were majorly focusing. Out of those 4, I'm going to talk about scaling. Scaling has impact on cost and performance, which is where most organizations we struggled. Now I'm going to talk about challenges that we faced while building SigView and NitroDB and how we overcome these challenges. Wait, can we go to the next slide?
Before we start there, I would like to learn a little bit about our audience in terms of the challenges you are facing in your cloud environment, so that we can put the questions in context. So I'm just sending out a poll that I would love for you guys to answer. You should see it on your screen, and you can just click the option that you have kind of seen in your organization. We're going to run it for about 30 seconds or so. If you have not responded, I would love for you guys to respond. So the question that we have in front of us is, what are the challenges your organization is facing? In our kind of experience, so I'll just close the poll and share the results. So as you might see the results on the screen, cost and performance are the 2 clear winners that most early organizations in their journey start to look at. But you would see that as your cloud pipelines mature, you would see data issues and stability as an important aspect. And traceability will soon become a very important aspect as you see these cloud pipelines run and be dynamically scalable and so on. So to talk about that journey, I'd like to kind of start off with Jagan. Jagan, can you address how we solve these problems?
Sure. So I'm starting off with the first and foremost challenge, which is slow implementation. So when we were building the product, most of our time, our feature, solution, or implementation used to fall in 4 areas. First one is we implemented the solution, but the cost is high and performance is average. We implemented the solution and the performance is good, but the cost is very, very high. The third one is we implemented the solution, but cost is good, but performance is very poor, and sometimes we couldn't able to implement the solution at all. So in order to overcome these challenges, we decided to change the way we were approaching solutioning. I'm going to tell you the key changes that we performed on the approach front. So starting off with the first change, adopted the right processes. So adopting the right processes for evaluation of stories like building POC, understanding shortcomings, evaluating tech choices, and the trade-offs to ensure performance and cost optimization goals are achievable. Then we let developers focus on their code development and reduce their support needed for build and deployment. we opted for a functionality and performance testing in order to release a quality product on production. Then we focused on the continuous feedback loop to provide timely feedback to the developers. We enabled the developers with complete visibility in terms of functionality, infrastructure, performance, cost by using monitoring and logging dashboards. With these approaches, we improved the velocity of developers by 80%, optimized the responsibility for dev team to focus more on the feature development. Now I'm moving on to the second challenge, which is cost. In the beginning, we felt that we are well under the provided estimation in terms of cost. But later on, within a few months, we started realizing the way our cost is increasing compared to the data volume is way too high. So in no time, we crossed our budget estimate and about to cross the double mark. We were able to meet our performance goals, but with many on-demand instances always running, which used to be idle post query execution, or as and when there was less data ingestion. So in order to overcome these challenges, we focused on the traceability part in terms of resource utilization by customer, by pattern of utilization, and their cost impact. So there were many actions that we performed, but I'm going to go through some of them. Starting off with the tagging. So basically we tagged all our cloud resources. Then as we tagged the resources, we were able to segregate cost by the customer, by the components. Then we started cleaning up unused resources. Then we made this as a practice, bi-weekly cleanup practice. Then we moved to controlled provisioning, resize the instances, change the instances family according to the workload need, moved all our Spark worker nodes to Spot instances, reserve instances of Hadoop clusters master nodes, moved to S3 from HDFS to reduce the storage cost and also the maintenance of HDFS system. So apart from that, we opted for Parquet format for data storage to reduce cost of S3. Then we use auto scaling and many more. With these practices, we were able to achieve 60% of our saving goals. Now I'm moving on to the third problem, which is performance. The biggest challenge was the consistent performance. Major goal from a ETL pipeline standpoint was data ingestion lag should be below 15 minutes and query response time should be less than 10 seconds consistently. So in order to achieve these goals set on the product front, there were multiple ways we opted for resolving these issues. Some of them were from operational front and some of them were from the architectural front. So I'm going to talk more about the operational front at the moment, and I'll cover the architectural changes in the later slides. So starting off with the operational changes. So this is the toughest challenge of all. We tried auto scaling based on single metric, multiple metrics, but none of them worked as expected. We needed. So eventually we moved out of AWS based auto scaling to a custom scaling. Just to give an example, we used to monitor our resource managers utilization, plus we used to see which user logged in, where we need to spin up machine. So we use the events and metrics combined to spin up and spin down machines. Our target was to launch all the machines and adding them to the cluster within 30 seconds, and which we were able to achieve. Along with this, the second challenge came in was since we were launching many instances on the fly and then turning them off as and when users used to sign off. So due to this, there were a lot of resources get registered on the resource manager, and then in order to resolve that issue, we use the APIs and scripts to clean them up on a time to time basis. Our workload was 100% on the spot, so there were times when we saw that spots are not available. In order to fix this challenge, we had written automation script which used to ensure that if the availability of spot is less in that particular region, then it used to fall back on demand instances. This has helped us to manage Black Friday, Christmas festivals very well. Now moving on to the last part, which is stability. So we were facing issues with the availability of pipeline, and also noticing issues like data corruption, data duplication, missing data. To fix these stability issues, we implemented the data ops practices. As part of the implementation, we took many initiatives. I'll walk you through some of them. So implemented service and component monitoring and set action automation to take corrective actions. Let's say if any of the service goes down, it will automatically go and restart it. Implemented framework to generate dummy data with different streams. So what it will do is like a parallel data will flow through the ETL. It will ensure that the data, the count of records been sent from the source till the destinations are intact. Then set up Hadoop, Kafka, Elasticsearch systems to handle failure and ensure data availability in case of any node failures. Use Spark to gather the count of data at source at a different stages of ETL pipeline and at the destination. And we pushed it to the database and used it as a input in the Grafana system. In case of data discrepancies, we used to show them on the Grafana dashboard, as in, let's say there is a corruption for a day or hour of a day, then that row will used to become a red, and immediately the notification used to get sent to all the respective team. And there were some action automation also set for issues, those fall into certain category. This approach has helped us to fix root causes of data issues, and also reduce our time to reprocess the data. Mayur, what's your thought on the technical challenges front?
Yep. I think as you can see, the changes and the improvements for different challenges can lie anywhere. Some of them lie in where your disks are, some of them lie where your networking is, some of them lie in your business processes and practices. So this requires both teams like the IT, tech, and business to work together in order to actually address those. And that can be an organizational structural change that you may see that cloud is bringing into your system. So I'm going to invite Jagan to talk about some of those aspects as well. So how do you kind of, improve your organization processes to cover those aspects as well?
Sure. So when we face the workforce issues like dev versus off, so it slowed down our time to market and delivery time. So we adopted the DevOps practices, analyze our current applications value stream, the series of activity necessary for moving application from development to production, onboarding new client since Sigmoid and NitroDB is a platform, time to resolve data issues. Then we started measuring areas where we were facing issues majorly, like production failure rate, mean time to recover, time to onboard a new customer on platform, then deployment speed, deployment frequency, mean time to production, time to resolve a data issue, frequency of data issues. Post this, we started optimizing areas where we were lagging a lot. Sorry, made this as an iterative process and ensured that we are continuously improving our infrastructure, application, and ETL pipeline. Now I'm moving on to the second workforce issue, which is cloud governance. Proper set of policies and procedures were lacking to support organizational strategies and business goals. So in order to overcome these challenges, we took various initiatives. I'm going to cover a few of them. Like as and when people used to spin up machines without any tag, or they used to tag them in a wrong way. So we used to take their backup and delete those resources just to tell them that, if you don't follow the processes, then you will have to rework those things. Then in the tagging process, we also added a tag which is called duration. If whatever duration has been set in the tag, according to that, the script used to delete those resources. We used to intimate the resources a day before. Then the next major initiative was controlling the provisioning of the infrastructure resources. So first, we enable developers by developing in-house application, which allows them to select predefined template for a cluster or individual instance provisioning. If none of them works for them, then that particular request goes as take it to the operations team, and they used to take it on high priority to ensure that developers are not blocked. And then we decided to revoke access of all the developers, and also added limit to how many instances a developer can launch or a team can launch clusters. If any resource is underutilized, then we have written scripts to notify those developers and teams, and scale down based on the, or resize based on the need. So we made the practice to clean up unused resources bi-weekly. That has helped us a lot. So
Makes sense.
over to you, Mayur.
So I think the overall process, as you can see, is kind of a continuous process. It takes, you basically look and isolate where the gaps are and kind of continue to mitigate them. And Jagan, we continue to kind of innovate on some of those things, and you can talk about some of those initiatives as well.
So there were many improvements we did on the architectural front. I've added few of them on this slide. I'm going to talk about the first one. We migrated user filters from Spark to Elasticsearch, which resulted in 40% of performance improvement and 25% cost savings. A user searches returned within 4 seconds on 1.5 billion records. There were many such initiatives we took, but I'm going to skip those for now. Well, can we go to the next slide?
Sure.
So in terms of the actual impact, the cost reduction, when we compared November 2020 to April 2018, it's more than 65%. And the annual saving is around more than 2.1 million. Our customer experience is better now, as query performance is increased by 40%, and we were able to reduce our infrastructure management overhead by 60%.
I think that's quite great. And if you look at apples to apples comparison in terms of the customers are now storing a lot more data with us, as well as the number of customers themselves have actually grown. So the actual improvement is actually much higher than the numbers that are stated here. But even the conservative estimate that we see is really astounding, and which can tell you that if both teams kind of work together and really focus on making cost and performance as the two focuses areas, there's a dramatic difference that can be made in the organization. So as a next step, what I would like to do is invite in AWS to talk about what do they suggest as the best practices for cost optimization. Kaushik, on to you.
Hey, thanks, Mayur. It was a great case study that we were looking into. I mean, I think Jagan has given us a lot of aspects that we need to be focused into when we are building this data pipeline and everything, right? So we generally recommend to follow on the well-architected practices, which focuses into the best practices around, like, cost, security, performance, reliability, and operational excellence, right? And if you look at data pipeline, like, there are about 6 areas that you should consider when building an analytics workload, right? For example, the data ingestion layer, data access and security layer, catalog, central storage layer, and then processing and analytics layer, and user access and interface layer. So broadly, we can just categorize into three, which is like, ingest, process, and storage, right? It's important to keep an eye on these stages and optimize the usage based on the requirement, right? And apart from that, we also need to keep an eye and like, leverage various tools for monitoring costs, like for example, monthly invoice, billing console, cost explorer, and budgets to have visibility over the spend, so that like, we take control of how we can optimize the cost continuously. And like, Mayur and Jagan said, it's not just a one-time process. We just have to keep on doing it continuously over a period of time to make sure the cost is optimized. So going on to the next slide, so I would like to focus on four areas, right? So the first being like, the cost-effective resources, which means like, effective utilization of resources is very key here, right? For example, choosing the right compute solution, on demand for testing, like, normally whenever we have a workload, like whenever it is in testing or like, trial mode, just go for on demand and try for it. And once we know the size, type, and spikiness, then we'll have to pick the right reserved instances, right? RIs. And RIs can be purchased for DynamoDB, RDS, Redshift, EMR, and Elasticache. And for transient workloads, consider using Spot instances. We can integrate Spot instances with Amazon EMR, AWS Batch, Data Pipeline, and etc. And can also integrate with non-AWS services like Terraforms, right? And Amazon EMR instance fleets gives a wider variety of like, options and automated intelligence for instance provisioning. Let's say, for example, you are configuring up to 5 instance types with like, different weighted capacity. Amazon EMR automatically provisions on-demand and spot instance capacity across instance types when it is creating the cluster, right? And the next important thing is to keep a tab on storage cost. See, as Mayur said, like, data lake can grow exponentially, and it's important to optimize the cost. So we have to make sure we have the right storage class and lifecycle policies applied on those S3 buckets, right? And ensure we have the right storage class, like for example, standard, infrequently accessed, and glacier with an appropriate lifecycle policy. And newer services, they allow directly to query in the S3, right? So we have to make sure like, we have a hive style partitioning structure to the S3, and we compress the data and store the data in columnar formats like Parquet, which can improve the query speed drastically, right? And for example, when you're using Amazon Athena, by compressing, partitioning, and using columnar formats, you can improve performance and also reduce your cost, right? And Amazon Redshift Spectrum, for an example, again, it charges based on the data scan. And since Parquet stores data in columnar format, it performs faster and much more cost-effective results, right? And at AWS, we provide multiple options to choose when selecting a storage layer to your analytical application. And the next important key area is like, matching demand and supply. So for data warehouse workloads, infrequently accessed data in the warehouse can be migrated from local storage to S3. And when the cold data is required for analytics, use services like Athena or Redshift Spectrum. And it is important to consider analytics workflow costs at each individual data processing step, right? And for example, if there is a costly ETL job running hourly, but the analytics is performed nightly, then reduce the frequency of ETL job as per requirement. And like, there are several factors that impact data processing costs. So for example, data storage location, data processing frequency, job concurrency, and data size per processing cycle, processing duration, and many such things, right? And the best practices when considering cost optimizing a big data workflow is to create a data pipeline model, and for each step, calculate the cost of the step considering the above factors. And the next one is like, be aware of your spend on AWS. It's important to track data freshness, right? And infrequently updated data can often move from relatively more expensive storage to relatively less expensive storage with a high latency, right? In AWS, data transfer charges apply to data transfer out of AWS, right? In many cases, it's cost effective to move data closer to the analytics tools in cloud rather than to pay data transfer charges. It is important to provide users and financial stakeholders visibility into costs for your analytics workload. Cost allocation is a shared tenancy model and requires a combination of logging and cost modeling to determine the correct price per transaction or workload. And the final one is like I just said, it's an ongoing exercise, right? And we just have to make sure we take the certain decisions that will be made based on the experience over a period of time. As AWS releases new services and features. For example, we recently launched Amazon Managed Workflows for Apache Airflow. That makes it easier to set up and operate end-to-end data pipelines in cloud, right? And we have AWS Glue Data Brew, which is a visual data preparation tool. And we have launched AWS Glue Elastic Views. All these tools can be used effectively to bring down your cost, and also to use your resources in an optimal way. And it is a best practices to review your existing architectural decisions to ensure they remain cost effective, right? And as your requirements change, be aggressive in decommissioning resources, components, and workloads that you no longer require. And consider these for two steps, right, to optimize over time. One, develop a workload review process, and review and implement services as you need. So this is what I would like to give our perspective out here, Mayur, and over to you.
Sounds perfect. And I couldn't agree more on the optimizing over time. I've seen customers who just kind of looked at their basic systems, just upgraded a couple of machines in their 2-year-old pipeline and started saving like 30-40% just like that. So I think this slide is worth kind of taking a screenshot of and putting out your desktop. And just as Kaushik pointed out, it should be like a monthly process that you should look at it, look at all your expenses and everything. It'll just make your life a lot more easier as you kind of migrate your entire environments to the cloud. So I think we're going to sort of summarize the webinar and head into Q&A. But before that, I would love to kind of get your opinion on what you guys are planning for 2021, and so that we can sort of align those aspects accordingly. So I'm going to send over another poll to you guys, and would love for your answers around the same. So the poll basically is just talking about what you guys are planning to implement in sort of the end of the year, which is just about 2 weeks more apart from Christmas. And then in 2021 on your cloud environment and ecosystem side. The different aspects there are like cloud governance, observability, data issues, and kind of really adopting data ops as a service on your side. I'm going to give it another 30 seconds and then we're going to publish the results. So I think in the interest of time, I'll just be closing the session. Okay. So just kind of talking about observability as being sort of very important aspect, and rightly so. I think the first aspect on your journey to manage the cloud environment is to start observing the cloud environment, as Jagan had pointed out. We're going to talk about some of those aspects from our learning standpoint as well. So sort of moving on to the takeaways from a webinar, what we try to do is sort of compress our learnings on the cloud migration journey into a framework that we have tried to adopt and apply to all of our customers that we work with on a day-to-day basis. So I'm going to hand over to Jagan to describe that framework and what has been our process in terms of optimization for our customers. Jagan?
Sure. So there are 5 phases to this framework, starting off with the first one, define. So define the problem, optimization activity, opportunity for further optimization, the project goals, and requirement or feedback received from internal team or customers. So define those and then measure. So measure the performance of activities performed as part of the cloud optimization. So measure the frequency of recurring cost, data, performance issues. So measure the process to meet the requirement in terms of capability, capacity, and feasibility. Then the third phase is analyze. In the analyze phase, analyze the process to determine the root cause of inflated cost, poor performance. Analyze the options available to overcome these challenges. And then in the fourth phase, which is optimize the performance and the cost by addressing and eliminating the root causes. The root causes may not be just related to the technical stuff, but also related to the process or workforce related issues. The fifth phase, which is control the improved system state in terms of cost and performance. Make people and team accountable for system state. Make optimization as reoccurring process than one-time activity. Implement the cloud performance and cost anomaly detection system to keep close tab on variation, and set up notification under and overutilized resources to gauge the probable outage, or to reduce the cost by resizing the instances. Over to you, Mayur.
Perfect. So I think there's two other aspects to this. I think one is that this is a cycle. You should keep doing this every so often, just like all the other things that we talked about. And then the second thing that is there is the cost to business value mapping. Cloud has made this possible now better than ever before. So your business would have to pay more if they want to look at 1 year worth of data versus same store still over, let's say 13 months versus like 2 years. So it's very important that we surface those costs out, and you map them to the business value that you're generating against the products that you're making, so that they have a good insight into how much they're spending and whether they need to spend that much actually to kind of get those reports or get those models running and stuff like that, and allows you to contain and manage those experiments. Second, I'd like to call in Kaushik to kind of summarize the learnings from the AWS standpoint as well. Kaushik?
Thanks. Yeah. So yeah, expenditure awareness is again a very key aspect out here, right? So how do we get this cost visibility? So let's look at the deck here, right? On the left, we have monthly AWS invoice. That's a very simple tool, and it provides a view once a month and breaks down cost by service. And second, we have AWS billing console, which provides a little more information over several months. And then we have AWS Cost Explorer, right? So use Cost Explorer to view costs for the month, like top cost trends, groups, and filter the data with a variety of dimensions such as services, member accounts, regions, purchase options, cost allocation tags, as well as custom cost categories that you can create. Not only does it show you costs, it also shows you how optimized you are. And I highly recommend you to try this feature, free service, if you haven't done so already, right? And also have a look at AWS Budget, which provides automatic warnings on budgets and targets for spend and usage and optimization. If this is not enough, you can always try third-party tools that are generally available in the market to analyze your invoice and cost incurred in AWS and get a good grip on it. So next, I would like to talk about the cost optimization levelers. Um, yeah. As you can see here, I mean, cost optimization comes with different aspects out here. Like for example, in S3 intelligent tiering, the data store cost can be optimized by using appropriate storage class, like we discussed before. And we can use like intelligent tire in S3, or like just use the right lifecycle policy to archive the data into the right storage class. And on demand for testing and RI reserved instances once we know the size, type, and spikiness. This is very important. Like we just have to make sure we have reserved the instances based on the consumption. And for example, the analytics compute can happen in two ways, right? One, easy to compute way, or serverless way. We have different techniques like using spot instances for transient workloads, or let's say we can take advantage of all these new Graviton based instances that AWS is offering to bring down the cost in analytics workloads. We need to keep a tab on DPUs, right? For example, in Glue ETL, keep a tab on how many executors are running from CloudWatch logs. And if the pipe has to run 24/7, we have for example, tools like enterprise discount program and savings plans and etc. And you can always work with your account manager and others to get hold of it and find out what that is. And for any transient workloads, use spot instances. I'm just saying again and again because this is a very key item here. And if the consumption is spiky and not want to manage them, then you can always try out serverless option. So these are some of the things you can do around AWS cloud, and make sure you have the cost optimization levelers in place.
Makes sense. That's a really great summary, Kaushik, and thanks for that as well. We have a bunch of questions here, but before I go there, I would like to kind of quickly cover who we are. So we are Sigmoid. We are a 200-member team based out of US, Europe, and Bangalore offices. We have been in operations for about 7 years, working with large Fortune 1000 customers, as well as large data-intensive startups as well. I think in the course of our journey, we have managed close to about 50 petabytes of data. And currently, I think we are processing about almost 100 terabytes on a daily basis across all of our customers combined. We have built close to 100 plus data pipelines. and kind of worked across all the major clouds, whether it's AWS, Google, or Azure, including some customers on the on-prem environment as well. So definitely, there are some areas where you feel that we can add value, whether in your cloud environment or others. Feel free to reach out and respond back to the webinar as well. And the second thing that I would like to point out is we'll be sending out a feedback. As you will close the Zoom thing, you will get a feedback. We try to do these webinars, I think once in 2 months or so. So if there are topics that you would like us to work on or things that we can improve in this webinar, please do kind of give us the information so that we can tune it better to what you guys need. And hopefully you found this content to be useful. So I think we can quickly kind of head into some of the questions that we have here. So I think the first question is for you, Jagan. It says, should we do any kind of capacity planning or forecasting in the cloud, or should we be fully dynamic in the way we operate? So should we do any kind of capacity planning at all, or just kind of, wing it as we go?
Capacity planning is the most underestimated problem of cloud computing. The right capacity management helps IT meet the dynamic requirement of the business while controlling and reducing the cost. If you look at the Sigmoid's product example, we analyze the capacity part, and then according to that, we worked on the scaling part. So just to give you a short summary about how to implement the right capacity planning, one need to understand what is there on the cloud now, understand the current utilization, resource utilization, understand the estimated future business growth, and align resource and cloud cost estimation accordingly. Determine the sustainability, production cost and performance, understand the production cost and performance objective, as well as support and governance objective. So I think with this approach, one can define or one can build a very good capacity for their infrastructure.
Makes sense. I think that there are other aspects to it as well that I can add to. I think from a leadership standpoint, it's very important to know that how much budget we need to set aside for different projects. So it's very important to do capacity planning to kind of estimate how much the cost is going to increase. And you're going to always miss out. Okay, maybe we didn't include data transfer cost. Maybe we didn't include, like, the spots will actually undergo a spike in pricing. So we didn't manage that. So there's going to be unknowns, and that's fine. But it's very important to do some level of capacity planning. Not to mention that if all the projects across the company do that well, you're in good position to talk to your AWS account manager to see if you can kind of negotiate into something good on your pricing side as well. If you're doing sort of some large investments onto the AWS ecosystem as well. I think the second question is there for you, Kaushik. How can a kind of a data ops partner add value? And what do you suggest from an AWS standpoint to help optimize AWS costs?
See, DataOps partners are crucial to enable self-service consumption of data. For example, they can unlock their data residing in silos within an enterprise IT landscape and provide secure delivery of up-to-date data to every stakeholder, right? So this enables rapid development and delivery of data-driven applications. And often our customers expect the DataOps partners to either build data lake from scratch or optimize existing data lake or the pipeline. So this could be a mix of ingesting data from on-prem or AWS or from other cloud providers. They bring in their expertise to the table, be it a real-time ingestion or to be to the data pipe or batch processing. The partners would be able to help in optimizing the usage of resource by using the right tail for the job and by following the best practices we discussed before.
Makes sense. That's really kind of a good perspective there, Kaushik. I think the other piece where we are seeing kind of data ops partners kind of add value is bringing a broader range of experience from since we engage with customers at different maturity level, we know what is the next maturity level that you need to reach to so that you're optimizing on the right things. that are there. I think this question is sort of for us kind of a thing. I think how do you trade off using open source and cloud managed services? What do you prefer and why? I think I can add something to that. I think what we have seen a lot of customers do is they start off with kind of lifting and shifting a lot of their existing workloads to AWS. This typically means you would see them, installing, let's say, Hadoop on AWS environment to begin with, just because they want to kind of, first see how it goes. So most starting of the journeys are by using open source on cloud environments. A slightly more mature customers then start to rely on open source managed cloud services. So like the Airflow service that Kaushik was talking about, that they launched recently, or it is EMR, which is Hadoop, which is AWS managed, where you get best of both worlds. So you get an environment that is optimized by AWS for their environment, as well as you work on open source APIs where there's a big community to support your developers, and you have like hundreds of questions answered on Stack Overflow on how to develop things. And then in some cases, you might want to go for like hyper optimized AWS systems, which may be developed as fully cloud managed systems. And that kind of, a lot of customers make that journey. A lot of customers stay somewhere in the middle. So it all depends on, your, what tools fit the best for your use case. I think we have one more question. Again, like, are there scripts in GitHub that we can leverage for tracking usage and cost and monitor ETL loads as discussed? I think, I think the question on GitHub or anywhere, like, should we manage track these costs on scripts or use one of the dashboards, and any insights into that question? Jagan?
Yeah, so there are different way to, there are different way to answer this question. First one is like there are tools which does this tracking. Then apart from that, you can also utilize AWS CloudWatch. The most important part of this is how will you gather those metrics and push it to certain system, be it Prometheus, be it CloudWatch, or even the Datadog kind of system, which offers a lot of inbuilt, metrics gatherings. So, I think there are few scripts available on the GitHub as well, which allows you to, gather metrics of your ETL, but those ETL needs to be very standard. But mostly based on our past experience, mostly you need to understand your ETLs and write code accordingly to gather the metrics out of it, and then visualize them on various dashboards.
I agree. I think some of the basic metrics on which you can optimize, like let's say your machine utilization or some of the basic metrics like that, I think CloudWatch and sort of auto scaling kind of handles those things. But in most cases, those are insufficient for data workload, because data workload will need to be tuned to what SLA of your data pipeline you are looking at, how much data you are processing. So sort of we want to make sure that we understand those metrics and scale our pipelines according to that. That is very custom to your implementation aspects out there. So out of the box, a script fitting that is unlikely. I would look at sort of what are the metrics that you want to tune your data pipeline to, and it's not complicated to link that to scaling, but kind of making sure and identifying what are the key metrics that you need to focus on, I think is the most important aspect that can be there. I think there's one more question for Kaushik here. How can we achieve cloud optimization by matching supply and demand? I think it's related to the slide of supply and demand that you talked about.
Yeah, sure, Mayur. Yeah. So it's a two-step approach, right? I mean, that's how I can see it. Like, one is demand-based and another one is time-based. So what do I mean by demand-based is we should be leveraging the elasticity of cloud to meet the demand as it changes, right? And it can provide significant cost savings. So within AWS, this is normally accomplished by using auto scaling, for example, right? And this has to be thought through, and also choosing the right instance type, size, whether you have to pick a big instance or like take a smaller instances, number of smaller instances. We have to really look into what is needed out there based on the demand, and we'll have to provision resources accordingly. And the next important aspect is time based and workload scheduling, right? So for example, a time-based approach aligns resource capacity to demand that is predictable or well defined by time considerations. Like for example, how consistent is the usage pattern, or what is the impact if the pattern changes. So we normally see our customers using a large EMR cluster rather breaking down into smaller clusters based on the usage or time. For example, if you need a Presto cluster between 8 a.m. to 8 p.m., and let's say you need only an ETL job to run on the night, and let's say you have a streaming job that runs 24/7, then we need to create 3 clusters instead of creating one big cluster. So for example, one cluster to run between 12 to 6 for processing, and another cluster for running analytics interface for 8 a.m. to 8 p.m., and for another one to continuously running cluster for streaming with spot instances. So we'll have to make sure that we adapt these two practices, whether to match the demand, or based on the time, we'll have to optimize our resources out here.
Makes sense. I think again, kind of a similar point of view that we have seen, like in the older days when we were working on the IT environment, like just because IT doesn't want to continuously keep setting up Hadoop clusters, we used to see sort of one big Hadoop cluster running inside the organization, which is doing everything, right? But now you're not there. Like you can actually design new Hadoop clusters. One can be memory based, one can be compute based. So you can sort of choose what works for your workload and then kind of really kind of use that, right? So there are still some fixed costs. I won't say it's, you should be like, it's very free, but I would say that the ability to optimize your compute instances or to the requirement can really give you a lot more gains compared to the small fixed cost that you may pay just because you're splitting all your clusters into multiple sets. Not to mention, like, I don't want to have, like, I worked with a customer where there was like a 5-year-old Hadoop cluster. They were like 5-year-old problems in that Hadoop cluster till date. Like, I was thinking if you're in the cloud, you could have just destroyed this and built this in like a weekend and kind of, got away from all those problems. But I'm glad that we live in this world now. So I think that kind of brings us to the end of the webinar, and it was a very interesting conversation that we had. And really thanks for the audience for the participation, both in terms of the polls and the questions, and also Kaushik from AWS for helping us out here in joining us today. I hope you guys found this whole session to be very interesting. And again, as I said, please answer back on the feedback so that we can tune these webinars to your future needs, as well as feel free to reach out to us to see how we can help in making your systems to be more productive and implementation. So thanks for joining us at the end of 2020, and look forward to a much more social 2021 next year, where we can meet some of you in person. Thanks a lot, guys. Have a great day.